I think it's working. Hello, YouTube. Hello, everybody. Hello, Ben. How are you?
Very good, Bill. It's good to see you
Yep,
once
great
again.
seeing you. So we have a special guest on today, Kelly Heaton from Kelly Heaton Studios, who does say hi, Kelly, and tell us what was the word we used? You were doing electronic wildlife. What do we call that?
Electronic naturalism.
That's it. I've blown it already. You get old and the memory fades real quick. So, but real quick, first before we start, we do want to do a shout out. Ben, take it away.
Yeah, I just wanted to say a huge thank you. I don't know if he's on watching this show yet, because he's down under in the outback of Australia. But Brendan, thank you very much. Brendan actually sent us some money to help us pay for everything we do. Up to this point, this is and still will be something we do because we love to do it. We love sharing our experience, thoughts, ideas, and then that of this community. Brendan's here. Brendan Mayer, thanks. He just commented.
Yes.
Great to see you, mate. Brendan was actually having some real problems finding software for legacy CPLDs, stuff that they don't make anymore. And Bill, you had held up that AMD Mark development kit, which I believe you sent off to him.
Yeah, it hasn't been sent off yet. It's going to cost $100 to send that to Australia, and the gentleman has said, "Yeah, let's do it." So I have to finalize the,
But that it brought up a whole point, and we'll probably talk about this in a future episode. We won't today, but in a stream coming up soon, we'll talk about this whole concept of vendors locking people in by software, hardware, or whatever method it is, but then later on just unceremoniously cutting that thing off so you can't maintain it anymore. And there's a lot of applications, and a lot of people in this community, we're all into, retro gear as well. It can be really difficult tracking down the software and sometimes the hardware. Like I've been looking for a programmer that'll support PALCE devices, and the algorithm was never published because it was a closely guarded secret.
Right.
So there's issues with lock-in, right? Because you can't go back and change something later if you can't get the software, or you've got the software but it won't work on a current operating system. So you've got to mess around with virtual machines and all that. But Brendan got in touch with me and wanted to send us some money. So it's going to pay for our StreamYard for a little bit, and it's going to cover the cost of our Discord server, which I boosted to Nitro level. And so thank you so much, Brendan. Just wanted to give you a huge shout out there. And Brendan's a great engineer down under, a fellow Aussie.
Cool.
And looking forward to seeing you have some success with that kit once Bill sends it off to you. So anyway, carry on. What have we got on the slate today?
So, well, I met Kelly first at Hackaday. Yeah, Kelly, you were there talking. You were presenting basically your birds and some artwork you've done. Kelly combines the physical PC board, and we're going to show a bunch of them, but combines the artwork of the PC board with electronics, right?
I would broaden that, but yes, that is one thing that I do.
Oh, right. Well, Kelly's an artist, so there's probably no limit to the palette she uses. So include in that the music and the sound artifacts, and and then, like I said, making the PC board itself part of the artwork, which as engineers, we see the artwork when we like go, oh, the impedance is right, oh, the layers are correct, But you bring a whole nother thing to it, and that's pleasing to the eye for people that don't see impedance and inductance just by looking. So that's all very cool. So you have a show going right now too.
Natural in a way, and I've always seen them as looking like plants or something. And then I situated my electronic birds and crickets in the garden.
I love it. They're really beautiful.
And that's why I say my goose was doing that earlier today, just letting everybody know he was there. Oh, wow. That's way larger than I thought it was till I saw those people walk in.
It's real garden size. And I've always kind of seen the same thing, even when I was a really young kid, and before I started learning about electronics at 8. But even before that, I had a 70s era transistor radio that one of my older siblings had that I pulled apart, and
Right. You learn to tune the slugs and everything.
Yeah, I would look at the printed circuit board, and all the parts looked exactly like those. You know, resistors were looped over to save space, discrete transistors, the whole thing. But yeah, I mean,
because we were just watching that video, the show has been extended to the 3rd
Yes.
of June.
Yes. So give us that address again.
It's the building is called 5 Manhattan West, but the actual street address is 450 West 33rd Street.
Okay. And if somebody were to search for it online, what would they look for? Probably your name, Kelly Heaton.
Yeah, my name, Kelly Heaton, Circuit Garden. Yep.
Yeah, and Adafruit just showed your video as well, I believe.
Yes, they did. Yeah. They've been so great. Speaking of open source hardware, woohoo!
Yeah. Right. Now, you had, in addition to some of the retro look, and we're going to show that, you and I were talking about like the ESP32 not long ago for actually doing interactive bird type stuff. Did that go anywhere, or did you end up sticking with the discrete components?
Well, okay, so that requires a little bit of background.
Okay.
If that's okay. So the reason that I make my songbirds and my chirping crickets out of discrete hardware, so analog electronic hardware, is that I'm really interested in the lifelike qualities of hardware itself. So no code, no recordings. So I'm a purist, or I set a rule for myself to just use hardware to try and produce these lifelike behaviors in my birds and so forth.
That's why I like that you've used the astable multivibrator as the foundation for everything, because look, that's the basic building block of any kind of. It's the first thing you learn when you get into electronics. I mentioned being 8 years old and learning. The first Dick Smith electronics kit I was given on my 8th birthday by my big brother, who was a tech. He gave me a soldering iron and a book and a kit, and the kit was, guess what? An astable multivibrator.
Right.
2 transistors, 2 LEDs, just a little flasher in the size of a brooch. They call the kit the electronic brooch. And look at this. So you're getting sound from it as well as light.
Well, okay, so hang on, because I feel like I haven't quite answered your original point.
Sorry.
But there's a great quote by Nikola Tesla that says, if you want to understand the secrets of the universe, think in terms of energy, frequency, and vibration. So everything is vibrating. Right. And that's the basis of all reality. You know, it's like, woo, it's like really deep. And consciousness is vibration. Brain waves are vibration, right? So I got the idea, what if I took just the very, very simple hardware to make vibration, and the astable multivibrator is one excellent way to do that because it's just incredibly simple. And how far could I push that, you know, to get something that seemed lifelike? So in the case of this project, which was called Deep Fake Birdsong, and I've gone on to use this circuit for numerous different adjustable songbirds, including many that are in Circuit Garden installation. It only has 5 astable multivibrators coupled together, and that's how I'm getting the adjustable pattern of the song. And because it's analog, there's like very subtle coupling and nuance between the components. And if you get like charge buildup on a capacitor and then you twist the potentiometer to reduce the frequency of a connected or a coupled oscillator, it's not an immediate response. I mean, it's immediate, but you get like a transitional phase, right? You get all that like lovely blurry analog stuff, and that leads to a lot of unexpected behaviors. So it's fascinating to me, and I love to think like you know, if I can make relatively convincing birdsong with 5 coupled oscillators, it's not a stretch to imagine human consciousness arising from, you know, the coupled oscillators in our brain with our 100 billion
Right.
neurons. I just think that's so cool. It blows my mind. Oh, and because in the other thing, right, and as we know, are us analog enthusiasts, when you take one oscillator and couple it to another oscillator, when you add that third oscillator, like the scaling of the complexity isn't linear, right? I forget the term, but each time you couple a new oscillator into the system, the complexity increases dramatically,
right.
and quickly becomes highly unpredictable. Anyway, so all that being said, that's kind of so to answer the question, what's the circuit in the large schematic? That's the deep fake birdsong circuit that I'm talking about right now. So it has
basically, yeah, it's an audio visual synthesizer just made of pure astable multivibrators.
Yeah, it's
and you can mix them and adjust. Yeah.
This is one instance of it. Can you see it?
Yes, we can see a little bit. I can try and bring up a picture of it too, because it's beautiful.
I'm wondering if we have any sound samples or video samples of what.
I can plug this in.
That would be cool.
So I haven't forgotten the question you were asking me about the chip earlier. I'll get back to that, but
okay, yeah, we have plenty of time.
We need to do the analog stuff first, though, because otherwise there's no context.
Right. So the analog is let me try and get us back going here. What you've done is pseudo randomness that, you know, Ben and I are now from the days of where everything is clocked. If we were to do this with an FPGA, everything would still be driven from a main clock, and we would have to simulate randomness. But with your analogness, you've kind of made it so you can it's not determined by a master clock.
Yeah, it's legit. And but this is the same reason why there's still a huge market for analog synthesizers. Just talking about only the sound side of it.
Yeah.
There is a massive industry in the music industry for pure analog synthesizers. Now, people will control them with computers. They'll send MIDI to a board that translates MIDI commands into analog voltages for control and pulses here and there for timing. But everything else, if you get a Euro rack, you know, you can put whatever, you can buy modules. There's numerous vendors, and it's a huge market. And so, and to that point, like the desire for randomness and the ability to have an infinite palette from which you can paint sound.
Right.
And just like we want an infinite palette for color, it's the same thing. That market's never going to go away. It's always going to be with us. People love analog.
Yeah, we want to work with like the actual like materiality, if you will, of electricity. I know that sounds weird because we think of it as immaterial, but in its own way, it has, as you say, this infinite analog palette. And working with that directly is so much more artistic and intuitive than coming up with a logical concept that you then execute in code, right? It's a different way of thinking.
I really love that piece of art, by the way. That my eyes on your site kept going to that.
Yeah.
Back of a, because we don't even solder printed circuit boards like this anymore, like we used to back in the transistor radio days. Often there was no solder mask and the whole thing was wave soldered. So it got this big, thick coating of solder on the backside, and it had a real texture.
And the traces aren't just traces, they're the available surface area. It's like the less they had to etch, the more economical it was, the less etching material. So they would do these huge lands like you have here. And I love the dog.
Sometimes power supplies are still done this way.
Right,
for heavy currents. But as an artwork with the, I guess you had to use texture that I don't know what I forget what you call the material you get that you can mold onto the canvas and then paint over it. Is that how you did this one?
No. So I actually, but if you want me to come back and turn the song on, the bird song on, I can.
I'm sorry. We will.
Yeah.
We will do that.
Okay. I can talk about this piece too. I just don't want people to be completely confused. I feel like we've been leaving them.
I know.
Yeah.
We go left, right, and center on this show.
All right, let me turn the bird on real quick. So
Yeah, let's see the bird.
Sounds. Okay.
Bill, can you make the bird bigger? Yeah.
Okay, and it's adjustable.
That is just brilliant.
Let me see if I can get it. So that's the circuit that you put up. And what I'm doing is adjusting the base resistor on, so I have 10 potentiometers, one for each base resistor in the all the transistors in the astable multivibrators, right?
Right.
So, yeah. So that's
in good old 2N3904s, very basic NPN transistor. Yeah, love it.
Yeah. Yeah, it's really simple. Anyway, couple together. So okay, Bill, I still haven't forgotten. I'm trying to catch up with you guys.
Yeah, well, that's my fault. I was jumping around all the pretty things. I'm like, look, pretty.
No, it's okay. You asked me about, because we had corresponded about using microprocessors.
Right.
Okay, so the reason why I was asking you about microprocessors is that while my birds and my crickets are completely analog electronic, when I put them together into an ecosystem, I need some way to sequence them so that they don't sound all of the time. They're not singing all of the time, right? And I actually did build an analog implementation called a Mother Nature board that I published on Hackaday several years ago as part of Hacking Nature's Musicians, my project there that, Bill, you heard me talking about.
Right.
But it's a huge thing, right? And it's just takes a lot of time. So what I ended up doing for Circuit Garden is I designed this Tree of Life board.
Okay.
And I put in the middle, so this one's not soldered up, but in the, sorry, I can't, in this area here, it fits an Arduino.
Okay.
So I went online and I found a really nice, generous guy named John Wasser, part of the Arduino community, and he gave me some code for just a simple pseudo random loop that turns the birds on and off so they don't sing all the time, and basically it sounds like nature.
Right. Yeah, I love the sound. Kelly and I are both bird owners, chickens and whatnot. I love the sound of my birds, just not all the time. So there is a time for birds to be quiet. Absolutely.
Yeah.
So, now, when you and I were talking, one of the thoughts we had was, could you make a module respond to another module and put a bunch in the room? So one squawks, two answer, one answers from that, and kind of go from there.
I definitely want to do that. So if anybody has ideas on that implementation, I'd love to know. But again, like the elegance of it is also really interesting to me, because I know there's definitely ways to do that, but I'm more interested in the spirit of it than I am in like just creating some sort of effect. You know, like I really like the philosophy behind it.
Very cool. Very cool.
Yeah.
How did you do this one we're showing right here?
Okay,
and I love the dog, because my eyes said this is a small thing till my eyes get to the dog and I go, oh, it's a big thing.
Yeah. Well, you know, I think it might be cool if I actually bring that piece over in front of the camera. I think you'll be like, whoa. All right, so you guys talk for a second. I'll get it because I can
All right.
see it.
Thank you.
Are you getting the dog as well?
He's around.
So yeah, very
Jack
cool.
Russells are cool dogs, by the way. I've had Jack Russells before. They're a lot of fun.
Yeah, I didn't recognize it. My wife is an ex-veterinary nurse and would recognize it, but I didn't. So
That's a Jack. That's
hey,
well, I would say it's a Jack Russell. It looks like a Jack Russell to me.
All right.
So, cool dogs.
So
Look
you
at that.
can't
It's
see
beautiful.
wow.
This giant thing.
This is what I see when I look under my microscope at a PC board.
So now you can see me here. The traces. Okay, I'm gonna turn it to the side and see if you can. Well,
Yeah.
You managed to get the solder look perfect. Like it's really shiny and reflective, not just like a regular metallic paint. So
Right.
is that actually coated in like somehow coated in a? It's hard to tell.
So can you see
oil film?
Can you see these little sorry, I can't know which way I'm going. You see that little artifact right there?
Yeah.
You make it out?
A little bit, yeah.
All right. I'm going to put this down and I'll tell you what it is. Ugh. It's super heavy.
It's heavy.
Yeah. It's huge. So I used my laser cutter to cut the traces out of a chipboard material. And then I used, oh gosh, I don't know, 6 to 8 layers of acrylic gel and iron-on foil that they use in the screen printing industry to build up that thick solder-like look. So it's foil I ironed onto acrylic gel.
That's amazing.
And then I mounted and then I laser cut a piece of canvas, which was the artifact I was showing you. You could see just a little bit of fraying on the edge of the fabric.
Right.
And I merged the laser cut traces with the canvas background. So it actually looks like it's on the canvas and when in fact they were made separately. And in the last step, and if you look on my website, you can find this. I'll try to find it for you if I can. Let's see. This piece is called White Stag. Because if you look, you can kind of see what looks like a white stag in the middle.
Yeah,
I see it.
I can totally see that.
It's like a Rorschach test.
All of the dimensionality, the shadow that you see, I screen printed onto the traces.
I love the contrast on that. I was wondering how you got it not to be just all shiny. So that's screen printed, huh?
Yeah.
Wow.
Well, the reason that I'm able to make like beautiful circuit boards is because I'm a screen printer. So this is actually.
Whoops, that's my fault.
Oops.
Yep, there we are. Oh, okay. Hold on. Let me show yours.
Is that one on the site too, Bill?
Yeah, I can bring that up on the site here.
Yeah,
hang on.
I see that's. I think it's that right there, and I think you just scrolled past it.
I don't know if this particular paper one is, but look, it's just it's on paper.
Oh,
it's
okay.
See?
Right.
Oh wow.
So that's
screen.
That's the screen print version of this.
Okay.
So that's the actual board. Yeah.
Yep. Yeah.
So recent years, getting art into the copper, surface finish, solder mask, plating, and silkscreen has actually been something that really took off in the open source community.
Yeah.
When was the first time you saw it and realized you could use that as a medium?
That's a great question.
And how did you actually start? Because to me, it's still a mystery I've wanted to put cool logos and graphics in my board designs like that, but I haven't had the time to research how people really get it done. And
Yeah.
like, look at this one. This is amazing.
Yeah,
So there's probably 3 or 4 questions wrapped into one there, but how did you get started with this and find out about it or decide to do it?
So I found out about it through conference badges. I mean, Phil, you know,
Oh, okay.
yeah, like the beautiful conference badges people were making for Hackaday and DEF CON.
Right.
And I remember when I saw them, it just hit me like literally a bolt of lightning, because I had been making electronics for 20 years. I've been a visual artist my entire life. And I also have a screen printing background that I picked up later on just because I was working with so many digital images. And when I saw badges, I was like, whoa, electronics, visual art, screen printing. It was just this aha moment. It all came together for me. And I realized, like, you know, I don't have a moment to waste. I need to start making aesthetic printed circuit boards. And I really think it's like a full-on legitimate artistic medium that just hasn't really gotten widespread attention yet. And I've been talking to some friends of mine who also work in this space, and we're going to try to pull together a show of artists who work with aesthetic printed circuit boards.
Okay, that'd be cool.
Yeah.
Yeah. Do they now? How'd you come up? How'd you create these colors here? I see the white. Is what's your silkscreen color here? White, and then the yellows are how are they done?
Okay, so the yellowish color. Let me see. I have a smaller version of that board right here.
Oh,
Right,
yeah, look at that.
Okay, this is the one you have in the image is big,
Right.
but this is small. Okay, so you can see where I've got the gold surface plating right on the exposed copper.
Ah, gold. That's right. You did say that before. Yeah.
Yep, and then I have a green solder mask.
Right.
And I've got a white silk screen layer. So from the perspective of board complexity in terms of manufacturing, this is easy peasy. So
Right.
when I first started, there's another, well, I'll get into that in just a second. But when I first started doing this, you know, I have made my own circuit boards, but it's quite a toxic process because
Yes.
proper etchant. I mean, it's a dream of mine one day to be able to make very large circuit boards that are just absolutely gorgeous, but I need a lot of money to do it because of the copper, the etching process, right?
Right.
That has to be done safely. But anyway, so you have to work with manufacturers. And I got the name of a manufacturer in Shenzhen through some friends of mine and began working with them. And obviously they had a lot of questions in the beginning, like, what in the heck are you asking us to do? And it was a back and forth learning process. But one of the things that I realized in that process is that it's to my advantage, at least in the beginning, in terms of learning how to make boards of this kind, to keep my designs as much within the scope of the ordinary manufacturing process as possible.
Right.
In other words, like, you can imagine, like, initially some of my thinking here, let me grab something I want to show you. Some of my thinking initially was like, I want to, you know, have like tons of colors, right?
Oh,
so
yeah.
This is one that I actually painted on. So I had the board manufactured.
Oh, wow.
I painted the birds on it.
Yep.
So I contacted a lot of manufacturers, said, oh, you know, I want to have like 5 different silkscreen colors and multiple solder mask colors with different transparencies to get, you know, like stained glass kind of effects. And I mean, so I found some companies that were like, okay, we'll do it. But I mean, I was looking at spending $10,000 for a run of one board.
Yeah,
Yeah.
it's outrageous. It's
Yeah,
outrageous.
because of all the layers and the colors and the custom. I mean, essentially, I'd be like taking over factory production for a couple days, right? I mean,
Yeah.
they're like,
you-
"Sure, we'll do
yeah,
it. Are you-"
every new thing you add is another pass through the system effectively. So
Yeah.
it's a multiplier. If because I've there used to be an Octopart business card that they had, and it had the full spectrum of primary, or basically the full spectrum of the rainbow, including black.
It was like a
on one side of
7-color
it.
printing process then.
Yeah, and it was, and yet they made enough of them because it was just a business card for Octopart, that they managed to negotiate a good deal with whoever it was that made it. But at the same time, it's like, yeah, you're probably going to want to make a lot of those.
Yeah.
Right.
And I have a question about this one. Did you have some of the white silkscreen directly over copper? Because that's
Yes.
outside of the normal manufacturing process. Manufacturers will see if you have silkscreen over bare
Yes.
Bare
copper.
copper. Yeah.
They don't
They
like
remove
that.
it. Oh yeah, no, I know they remove it. Well, believe me, I have learned that lesson the hard way. So the manufacturer that I worked with on this particular board there was a sales rep who's unfortunately not there anymore, but he was amazing. You know, he spent so much time email back and forth with me to try and understand what I wanted, including me saying like, I want the silkscreen ink on the metal. And the thing is, like, it's not that they can't do it.
Of course you can.
We used to do it all the time. Yeah.
It's not stable. It wipes off or whatever. So they don't like to do it because there's probably some step in their cleaning process before they pack the boards for shipping, and maybe it gets messy or removed. So anyway, whatever.
Right.
So so you're right to point out that is like an anomaly.
Yeah.
I know Euro circuits in Europe can do some of this because they partnered with Boldport. You've probably seen these. This is a Boldport design.
Oh yeah, Boldport also makes beautiful boards.
Yeah, so this one is always on my desk. They sent it to me some time ago, and it's less elaborate, but it's still. But I know. I know in Europe there's a good manufacturer who and I know actually the guys that do all the marketing and run that shop.
Please give me that information. I'm always looking.
Yeah, absolutely. And they're really super clean too, because they're in their factories in the Netherlands, so they have an extremely high standard for environmental protection and high quality of output. So
that would be awesome.
Yep.
Who did you end up using out of Shenzhen?
King Creedy.
Okay, yeah, I don't know them.
Yeah, I know them because they worked with the Media Lab, MIT Media Lab, and a grad. So that's how that came to be.
Got it. So yeah, we were talking about this one before the show. You've got a meander here coming out of the bird, and we were talking about the resonant frequency and whether you can make a Bluetooth antenna right in the middle of your.
I saw that and immediately saw a Bluetooth antenna. That's just where my mind went.
I saw a delay line. That's
a Bluetooth bird right there.
Here you go. This is the
wow.
Yeah.
Oh, I like the height of the capacitors. It gives it some three-dimensionality.
That must have been a full-sized panel. Because, a standard fabricator panel is 24 by, what is it built? 24 by 14 or 24 by 18 or something?
Yeah, I forget.
Well, many of the manufacturers can do like, I used to know this better when I was producing larger boards, but 24 is basically like that would be your maximum width, but then you could do up to like 10 feet long but you're restricted to that width.
Yeah.
You know?
Yeah, Dave's confirmed it is. Yeah, I remember that from my IPC training. It's the standard fabrication panel is 18 by 24. And
Right.
you can, yes, you can get larger boards made, but that's where your costs start
Suddenly
to blow
the
out
costs
because
skyrocket. Yeah.
it becomes very
Yeah.
specialized at that point.
Exactly. Yeah. Not to mention the shipping and all of that. But yeah, like I looked into doing some larger boards with advanced circuits because they have a large facility. But the cost was just absolutely incredible. So hopefully one day I'll get a commission where I can go for it, because I would love to make just a huge monolithic circuit board. I think that would be
Well,
so awesome.
The manufacturer may actually partner with you and be part of that commission because
Yeah.
it's
Right.
marketing for what they're capable of, and
Yeah,
that's a
you
big deal for a lot of the margins are so thin in the PCB manufacturing industry that everyone's looking for some kind of edge that helps them find good customers. So
Anson Bao, if you're out there from PCB Way, give us a call.
yeah, why? We should they should give us an affiliate link.
Yeah.
Yeah.
Yeah. Oh, this one's beautiful. That I just now the one I pulled up while you were talking, is this one painted as well, or is this
Yeah,
one?
that was one I pulled up just a minute ago. Here.
Okay, that is the same one.
Those
Okay.
are beautiful parrots.
Yeah, I just
did you have to use a special kind of paint to make sure it adheres well to the board surface?
No, it's just acrylic.
Okay.
I mean, acrylic will stick to the metal, no problem. I mean, I wouldn't like go scratching it with a knife.
Yeah.
Right.
Yeah.
Right.
I guess
Yeah,
peel strength
beautiful.
is something we care about for solder mask and board lamination layers, but for paint on top of the board, it's probably much less of a concern.
Yeah, well, but you raise a really cool, interesting point that I like to talk to my artist friends about, the people who work in this space. Like, it's such an exciting challenge to make an aesthetic circuit board, because it's like figuring out, well, how far can I push this to make it really beautiful and really artistic and still have a functional circuit, you know?
Yeah.
Right.
And that's such a fun challenge, and it's hard. It's really hard. The board that I showed you earlier, that would be a good video to pull up. The Tree of Life circuit board that I made for Circuit Garden is pretty cool. It's on my Vimeo. If you go to, where would you find that? If you go to my Vimeo page, it's there. You can also find it.
That's the second tab there, Bill.
Is that it?
No, that's me making jokes about cryptocurrency.
Was that a Bitcoin struck chocolate?
Well, exactly. You know, get it? Bitcoin, haha.
Uh-huh.
Back when everybody was like freaking out about anyway.
I have another related question. Can people buy kits to make any of these off of your site? Is that one way that you help getting support for your work? Or is everything kind of one-off and you like to keep it to yourself but share the design? How does that work?
It's so you know the German phrase "Jein"? Okay, yes. Here we go. That's my Tree of Life.
Neat.
Disguised as a 555 timer. I love it.
Exactly.
Yes.
Inside Brilliant. Of the 555 timer. So there's more images of that. If you go to my Twitter or my Instagram, you can find more documentation and pictures and whatever. But that particular board, though, where I was working with the luminosity of the fiberglass substrate, backlighting it, right?
Yes.
Wow.
Yes.
Yeah.
Yes. So
that's another whole angle for PCB art that we can
Wow.
Well, yeah, absolutely. I love that quality, the luminosity of it. It's fantastic. But that board, when I went around and systematically removed parts of the ground plane to form like the leaves and the shape of the tree, and where you can see at the base, where underneath where the Buddha is sitting is a miniature of my circuit garden design. Anyway, when I removed the ground plane, I removed a lot of ground plane.
Yep.
I thought that I had my layers set so that I had my ground connections explicitly. Well, they were in my original KiCad file, but for whatever reason, it's easy to screw up, so those explicit connections also.
We've all been there. Yeah. Over the years, we've lost our ground at least once. Absolutely.
Oh my God. The amount of time it took me to rebuild the ground plane on that board, like it was days. Anyway. Yeah.
So you just answered a question I was going to ask, and that is, you did this in KiCad?
Yeah.
Okay.
Yeah, I do I mean, for cost reasons, I try and use free software as much as I can. I'm super grateful for that, because it's just where would the electronic art community be without open source and free tools,
Right.
Yeah, I mean, if your job isn't designing circuit boards for professional circuit board design, there's no justification when there's tools out there that are good enough. But I think the other thing here is someone had written, maybe it was the Boldport guy, I'm not sure, but I believe someone made a series of plugins or scripts, right, that allow you to import work done in Inkscape, which is also free.
Okay.
I'm just curious about your method, because you must start with your art, which is, I would guess, is completely hand done, because you're an artist. You draw, you illustrate, and you paint. So you start there, and then somehow you have to get it into the board. And that, to me, that's a massive challenge.
Okay, so depending upon the board, there are slightly different pathways, but I will try and explain the basic general way that it works. So I always start with some kind of concept that I know generally electrically and visually where I'm going. Like, I have a vague notion on both sides. The next thing I'll do is to design my circuit in a breadboard, and then I transfer that into a schematic.
Yep.
And once I have the schematic, I have a general sense of how much space the circuit will occupy by requirement, right?
Yep.
I have some idea. And then what I do is I decide what I want my visual composition to be. And by composition, I mean just like the kind of architectural, like what's the map of the image. And then I create, either drawing by hand or in Illustrator, I create a fairly accurate 2-scale diagram, where in the back of my mind, I know more or less where I'm going to place the electronics. Like for example, in the Tree of Life board that we were looking at just a minute ago, that I think there's a picture of that on my website. The Tree of Life under my Circuit Garden project. If you go to Circuit Garden, you can scroll down and find it. That's a detailed view, but yeah.
Yeah, it's not expanding for me. Hang on.
Oh, okay. Sorry about that. I'll have to update that. Nope. But anyway.
This takes me back.
Yeah.
I love it.
Oh, my inspiration. So yeah, sorry about that. Maybe in my blog you can find one, but it doesn't matter. The example I was going to use from that, though, is I knew I wanted to place the relay switches So the relay switches are positioned in the Tree of Life, like Bodhisattva are positioned in the Tree of Life in Tibetan Thangka painting, if you've seen that. It's like a classical style of Buddhist image. Okay, so because I know the relative size of my electronic components, I know what I want the composition to be. I make my Illustrator diagram. I export it from Illustrator as a DXF file. And then
okay.
I load the DXF file into, it's DXF or SVG? I'm forgetting it right now, but it's one or the other that KiCad will allow you to import. And I put that on the like user comments or user drawings layer in my KiCad file.
Okay.
Right? In the PCB layout.
Yep.
And then I'm able to go and to take my rat's nest of electronics and I place them within that DXF file.
Right. Yeah,
Okay,
that gives you your boundary, you know where the board edge is going to be. And then I'm just thinking you must have a lot of layers.
Well, so
it has to be divided up into some very special layers because you wind up with copper, solder mask openings.
Right.
Silk screen.
Yep. So what I do next then is once I've laid out all of my traces and I have like a functional circuit in KiCad, I export all of the layers that I know I'm going to need to modify artistically. I export them as a PDF file or a PostScript file.
Okay.
You can print to PostScript as opposed to Gerber.
Right.
And so then I take my PostScript file and I load it back into Illustrator or Photoshop, depending upon what I'm doing. I make edits to the layers. I make sure that everything is all lined up how I want it to be. And then I save those files as bitmaps. And then I convert the bitmaps to Gerbers.
Wow. Okay.
Yeah,
there's a lot of steps to that process.
Yeah.
and there's
it's
some
beautiful.
additional complexity here because in this board I'm not just seeing it's not just copper, solder mask, and silkscreen. You've got Boolean operations in there where
right.
You've got XORs where you've taken one shape outline and where there's a copper trace.
Yeah.
I'm not sure if I'm seeing it correctly. It might just be openings in the solder mask, actually.
Yeah.
But in some cases,
it gives the appearance of exclusive OR. Yeah, it's beautifully done.
It's actually a trick. My brain played a trick on me there.
Yeah,
but there may be a need for that in some designs.
It's not your brain actually isn't really playing a trick. I am doing exactly what you're describing. I just have to do it all manually because right now there is no tool for artists to be able to do this sort of thing. And so I have to figure it out all by eye using multiple layers in Photoshop or Illustrator.
Right.
And it's it like literally makes my brain kind of feel weird. Like it
can be very tough. Yeah. Even designing a regular printed circuit board, sometimes when you've been at it for a few hours and you're staring at your monitor, your eyes, you can start to see things double and in weird ways if you're tired or whatever. Something else that I wanted to comment on here is you've got shading in the copper down in that Buddha image.
Okay, that's when I'm using my screen printing technique.
That's what?
That's where I'm using my screen printing technique.
Oh, okay.
I have a piece that I need to go grab. You guys need to see it because it's pretty crazy when it comes to circuit boards. So
because generally with the we do with the PCB manufacturing process, things like shading, you have to basically use dithering to do it. So it'll be interesting to see how it's done.
Well, it's like the image of the Buddha is almost like the old-fashioned bandwidth test in the test pattern, where the spikes get smaller and smaller, which goes up and up in frequency.
All right, so this piece.
Oh, look at that!
So
you got some angels playing harps even on this one.
Yeah, cool. Well, and those are like all of this. Sorry.
So that's ink on the PCB substrate, or actually
No.
that's not a PCB because it's too big.
Yes,
but
it is.
It is?
Yes, it
Wow.
is.
Wow.
Wow. Wow.
And so is that in the back, which is backlit. See how you can. So
Right.
those colors that you're seeing on the Cupid and on Venus, because it's metal, I'm using the same kind of techniques that Louis Tiffany used in stained glass to make Tiffany glass. So I'm using like gunmetal patinas. I have a version of this particular piece where I've used green copper patinas. Like, I've been doing in the last several years, like a lot of experimentation with like, what are all the different things that are achievable in aesthetic circuit board printmaking. It's an electronic printmaking medium is what it is, right?
Yeah.
Right. Right.
It's just like it's a niche. It's a niche because you've got to know a lot of stuff. You have to be a printmaker and you have to be an electrical engineer.
Right.
But truthfully, you know what though, with open source being the way that it is, you don't even really have to be an electrical engineer per se. You can take an existing schematic and push it into a circuit board printmaking language.
Right.
I mean, I don't know.
Process or something. Yeah.
I say that, but and then I'm like, oh, you know, if you didn't know what you were doing electronically, I think the likelihood your board would work would be very small. But
yeah, you need
spend a
to
little
learn
money
the
getting
minimum.
it right. Yeah.
You need to learn the minimum. But you know what? I think, you know, a hobbyist level understanding of electronics is definitely enough.
oh yeah, totally.
Really the hard part here is getting the techniques and going through that process and knowing what you're looking at so it comes out right. Because
Yeah,
otherwise
I mean,
you're blowing hundreds of dollars on a custom board run and it might not come out right.
but compared
Yeah.
to what you guys do electronic, like the electronics, the circuits that you guys design and build, I mean, they're like a million times more complex than the circuits I'm doing. I'm working, you know, I'm like analog oscillator girl with a little bit of Boolean logic, some basic Arduino where I borrow code from the Arduino community. You know, like I'm not saying that my circuits aren't interesting. They are.
They're art. They're art.
They're art. And I purposefully keep the electronics simple because the message of my work doesn't need engineering complexity. It actually needs engineering simplicity is what it needs so that people can relate to it.
Right.
And that was the first thing that struck me is I used to build circuits more like what you see on the inside of the bird here. I didn't use a breadboard as a kid. I strung the leads from lead to point wiring, we called it.
Yeah.
And so I built an awful lot of, I built a synthesizer using very minimal PC boards, no breadboarding, you know, during the process, and a lot of point wiring.
Oh my God, Bill, I love that so much. So I really want to make these giant sculptures of free-form dead bug electronics, just like
dead bug. That's
colorful wires and beautiful, just because the sculpture of it is gorgeous, right? It's so neat.
Right. Yeah, we used to do what was called dead bug art when I was a technician in production. One time somebody had squashed a dead bug and I made a bunch of 555s gathered around it like they were mourning the dead bug upside down in the middle.
Yeah.
And before it was all done, I used to do like balsa and tissue airplanes. I built a pair of wings for a 555. So the next day he walked in and the thing had like been reborn as a butterfly 555.
Yes.
And, you know, and what they said was, you have too much time on your hands.
No, I don't think so. I really think that, and this is where the art comes into play. Like, you know, engineers know how remarkably lifelike electronics are. And I think that's a big part of the engagement. Like, I think, and I mean, the electronic naturalism piece is not just a stretch. It's not like a weird idea. Like, electrical engineers know that their electronics have character and have these lifelike qualities, you know, and you relate to them.
Yeah. Yeah. I just noticed the resistors for toes, for talons. That's really cool. That's really cool.
Yeah. And this one obviously responds to light and dark as well, because I see a bunch of light dependent resistors in there too.
It does.
Yeah. Yes. Yeah. There's a photo resistor in there. I see it. Cadmium sulfide or something.
Yeah. Yeah. That's it. That's very cool stuff.
What kind of dog is that? We were talking about that while you were away from the...
He's a Jack Russell.
That's what I said.
Yeah, that's what he said.
I've had Jack Russells. They're beautiful and a lot of energy.
Yeah, he's a good boy.
So what's this one? This is a breadboard used to control a bunch of birds all gathering and having a conference together.
So that is the Tree of Life circuit that we were just talking about.
Yep. Right. The prototype.
It does the same thing as this board does, except this board does it analog. So this is what I call my Mother Nature board. Wow. And I talked about it as part of my Hacking Nature's Musicians project. But what it does is it sequences the timing of those birds singing.
Okay,
cool.
Right.
That's very cool.
But analog. So there's just like a lot of analog and, you know, and or gates that I made transistors.
Right. Neurons.
Yes, neurons, totally.
Oh,
that's cool.
That is very cool. Folding a bird.
I forget what that's called when you ortho
low poly or
there's a program that you can, there's an open source program, like I looked at it to make a stormtrooper helmet or something like that. Or
Blender would be able to do this.
I modeled all of these in Blender. Yeah,
Blender, because Blender will give you the wireframe from your solid.
Yeah.
And then from there you can flatten it out.
Yeah.
Because that's part of Blender. Even if you're making a 3D movie, you have to flatten out the wireframe to give it a skin.
So I actually export the OBJ files from Blender and then import them into Pepakura, because Pepakura.
That's the one. Thank you, Pepakura. That's what I've heard of that one.
I'm going to write that down and look into it.
Yes, thank you.
All the time in the world to do another thing.
My brain was going to hurt the rest of the day if you hadn't said that. So thank you very much.
How is that spelled? P-E-P-P?
P-E-P-A-K-U-R-A. I think Pepakura. Yeah. It's a great little, it's not free, but it's not expensive. And it's a very nifty little thing. You can define the seams really easily to flatten out paper.
Right.
Yeah.
I was looking into Blender and Oski Studio this week, Bill, because we, just so everyone knows, we were having offline conversations about we need some branding. I wanted to get something going like that. We want some bookending theme songs. So I started recording some music in K-Chord for us. And in the process, I'm like, you know what we should really have is oscilloscope.
Our oscilloscope. I wanted to do a 2D oscilloscope or 3D oscilloscope art one time, and my digital scope won't do it.
Well, there's these guys who pioneered the oscilloscope music.
Yeah, right? Jerobeam Fender.
Right, and they created, or someone associated in that scene created a little program for making the audio files to drive the waveforms to draw the pictures. And there's a Blender plugin that comes with it, so you can take your 3D wireframe from Blender and create the audio sound in left and right channels that will create. You can have like in his demo on YouTube, he has a monkey head rotating on the oscilloscope screen, and then you can change the pitch of the waveforms so it keeps the same shape, but you can pitch it, and therefore you can make music.
Oh wow!
So I thought maybe I need to create a theme song for us. And the cool thing is, because it's waveforms for driving an oscilloscope, it sounds like chip music. It's just random.
Right.
I absolutely love that. Will you please send me a link where I can learn more about
Yes. Yes, I'll forward it on. Oski Studio's not free either, but it's only, I think they only wanted 39 euros or something for it.
Okay.
And that would save a lot of time, because they've made it really easy to end up drawing the images on the oscilloscope screen and then modulating them and all these different effects you can do. So anyway.
Yeah, I'm just amazed by the different the different styles you could create. I mean, you've got the theme of a bird and a circuit board here.
This one's
then,
nice. I
I like
so
this
you've
one.
obviously used the copper as a mask on the back so you can backlight the whole board, right?
Yeah.
I'm looking for, I can grab that one if you want to see it in a different. Yeah. All right.
Oh, that one's cool.
Oh, look at that. There's a lot of time in that. Making the actual 3D sculpture soldered up from resistors and parts. So there's someone else doing something similar to this. Is one of the guys, I think he's from the founding team of Particle. I could be wrong, but he posts on LinkedIn little functional circuits that are all put together with copper wire. We'll have to see if he'll join us one of these days too.
Yeah.
Oh, look at that.
See, yeah.
Very cool.
And that's just standard FR4, correct?
Yeah.
Whatever the run-of-the-mill material is, standard thickness.
What's the largest PC board you've done?
Well, probably the Pretty Bird. Yeah, for the reason, or the parrots, the painted parrots, basically like maxing out what I was capable of doing.
That was the max. Okay.
By 24. Yeah.
Right. I love this one. The detail in this one, and the time and effort that went into it, and the fact that it's a nest with it, and there's even like a little opto display in the nest. That's very cool.
It's brilliant, and you can color using colors of the actual components to give sense of the colors of the bird and
the blue.
Really pretty. Really pretty.
Thank you. I'm glad you like it. Yeah, the little components in the nest, like sort of, they make a squawking sound like a baby bird squawking at its.
Oh wow! I didn't even think it was functional. I'd never even thought about that. That's very cool.
All of the things.
All of them are functional. Yeah, I should have known.
So Kelly, I have to comment on this because I just feel a little bit of a thing here, right, in my chest, looking at this. This is really beautiful art that appeals to me because I'm an electronics guy. At the same time, this is making some kind of poignant message here, because some of these birds 1,000 years from now aren't going to be here, and the only way to reproduce them will be through robotics, and it's not the same.
No, it is not. No, in fact, so
I don't want to end on a downer, by the way. Like,
no.
I'm just saying, like, I feel like your art actually has an additional message that people need to pay attention to, and I want to know, like, how can people support what you're doing?
Yeah.
Well, great question. They can commission me to make art, or they can buy my art. As far as kits go, like if people want to be supporting me on a more like a lower level, I am in discussion with some manufacturers about producing kits. It hasn't happened yet.
I really think you should do that.
Okay. All right. Yeah, a lot of people have asked me about it. So
there's definitely a demand, and I think it could actually be a really good thing in the education space as well.
Cool.
I think what you're doing, the deep fake birdsong kit, if it were a kit, the bird with the I think it was 5 astable oscillators,
right?
Yeah.
Could be a fantastic high school project.
Right.
Cool,
or the
yeah.
Arduino driven, you know, just the inclusion of an Arduino, which would give kids the ability to take the same sculpture and make it behave in their personality or in a song they hear, you know,
Yeah.
through programming. That would be cool.
Yeah, that's awesome. And if people have other ideas, like please reach out. You know, I'm always open to collaborating. And also from it's again, not to be a downer, but yeah, I mean, nothing that I make compares even remotely to the majesty of nature. And it's really, I think it is really important. I'm glad that you touched on that. I would like for people when they look at my work to be reminded of how incredible
Realize,
nature is,
yeah.
and how important it is that we take care of that natural, you know, majesty.
Yeah, absolutely. Absolutely.
Yeah. So great. Well, excellent. Let's end on that high note then. We really appreciate you having you on. Geez, I can't talk today, but just wonderful stuff we're looking at here. This is
Thank
fantastic,
you.
Kelly.
Yes,
Thank you.
absolutely
Thank you very
brilliant.
much, guys. It's been great talking to you, and I hope we can circle back around in a while and catch up again.
Yeah,
Maybe we'll
wanna
sell
do
a
it.
line of your kits or something for you.
We'll want to do an
Let's do
update.
it. Let's do
I've
it.
kit thing. I've sold kits online, and I've done it the hard way. So if you want to circle back with me as well later, we can talk through some of that if you want. I just think you're really onto something here, and it's definitely something we should all be supporting what you're doing.
Thank you.
Yeah.
Thank you very much.
Yep.
So excellent. Well, again, it was wonderful having you on. Next week, Ben, we're going to be talking about virtual machines probably and how to use them in the development environment.
Yeah, I mentioned before Brendan again, and we got chatting, and I thought this is something we need to talk about. Is a lot of us in this community are dealing with old stuff and new stuff. And the way software companies are constantly pushing, not just software, mainly software industry, but also any tech company, we're always pushing people to do something new and to adopt the latest version and whatnot. And that's fine, that's good. There's goodness in that, but at the same time, we run into big problems when we're trying to restore or maintain older things.
Right.
And do retro computing and other projects like what a lot of us are doing. It can be really difficult getting information, getting old software working again so we can maintain something or update it, finding support for old chips. Like this is a big deal for us in our group. So I thought we could talk about that, and I'm trying to work through, because even the virtual machine software keeps getting updated so aggressively,
Right.
that yes, we use virtual machines to maintain older versions of operating systems and whatever it is, and they break periodically because an update will come out and then it'll cause something.
And
to
a
become,
USB driver or some silly thing.
It is insanely frustrating.
Right.
Um,
Yes.
So I just thought we could run down that rabbit hole perhaps next week.
Yeah, I actually have a piece of hardware I can't use because the driver was signed for Windows 98 or something like that. Kelly, I love this one too, by the way. I like the hand-drawn schematic in the background. That's wonderful.
It's really cool. You're a really very talented painter as well. Obviously, not just with acrylic or oil, but you're also doing water
Color and light. Yeah.
It's just
textures.
Brilliant.
Yeah.
It's brilliant.
Well, thank you. Thanks, you guys. I also make perfume, by the way. You can buy my perfume.
Yes,
wow.
I did read that on your profile. Actually, I read that on your.
So you're going for all the senses.
I'm not stalking you, but I did do a quick read up on your wiki before the show.
Cool.
Yeah, make a wet bird smell.
I'm an energy artist, Bill.
I believe it. I'm a burnout engineer, so it's kind of the opposite side of that.
Actually, Kelly, I think you've discovered some truth there too, because as professionally trained electrical engineer, you learn pretty early on that there's weak force in the universe. That's things like gravity. The strong force, things like electric and magnetic fields.
Right.
And everything that happens in nature happens because of those fields. Like people, when you first learn basic electronics, you don't realize this, but everything, every thought you have in your mind, every synapse in your brain is using electric potentials and molecules, ions,
Right.
and
Yes.
we could say, well, these molecules are moving back and forth. Yes, but it's actually without electricity, without electromagnetic fields, none of this would be possible.
Right.
Nothing would exist.
Yay.
And if a universal constant was off by 0.001%, none of us would exist in our present forms either, for those universal constants that drive the weak forces and strong forces.
Right.
Yeah.
Right.
Yes, that's why we can say we are all perfect and we are all one.
Yeah. Yeah.
We're all part of the
Perfectly
same
there.
group.
Yes, we're
Right.
all part of the same circuit.
Electromagnetic
Yeah.
energies
Just, you know,
everywhere. It drives everything. So yeah.
Just
So-
try to be for harmony and not dissonance, right?
I was going to say, but there's harmony and dissonance, right?
Yeah. Yeah. We're gonna get real philosophical.
Yeah,
now.
we're going to stop there, or
Yeah.
I'll start quoting the Silmarillion or something like that.
I know. Oh,
No,
Silmarillion. I love that. I love the Silmarillion.
Right.
Big
Yeah,
fan-
there
big
is
fan
no.
of Tolkien here.
Right.
Anyway,
So
Brilliant.
final note is VCF is in 2 weeks on the East Coast. If you're available, April 22nd, 23rd, 24th. Owl Charpentier sounds like he will be there Saturday also. So please, if you can't make the 22nd because it's a Friday, try and make the 23rd. It should be a lot of fun. We've got a gag of at least, we're getting around 10 Commodore people now. So people that you may have read about or heard about, you might get a chance to meet them. So swing on by if you're on the East
Fantastic.
Coast.
And to that point, we're not yet 100% sure whether we'll be streaming on that day or not because of VCF, correct, Bill?
Right.
But we're going to decide. We'll figure out. If we do, it's probably just going to be a live camera feed for that hour.
Right. If
And
we do,
we
it'll
don't
probably
know
be
if
Dave Haney and Andy Finkel. Yeah.
Right. So we don't know if that's going to work. We may just take a break on that day and encourage people to get there if you can. I don't think I can get there this time, but I'll look at whatever airline points I have and see if Bill will let me.
Well, there's a
sleep in
West
his
Coast
lounge room
VCF
floor.
coming up in August as well. So
Yeah.
there's always a second swing at it.
Yeah.
So excellent. Well,
Okay.
Kelly, thank you again for being here. Ben, as always, great talking with you. And we will see everybody next week.
Yep.
Thanks, you guys.
Take care.